this is Ms. Park, and this video is on similar triangles. Okay, so I've written a statement at the top which says triangle ABC, and then this little squiggle sign. The squiggle sign, we read it as is similar to triangle DEF. Let me tell you what similar means. Okay, if I have two triangles that they look exactly the same, so let's pretend that these are exactly the same, these two triangles are called congruent. Okay, the word congruent means that the triangles are exactly the same triangle. So this side equals this side equals this side, and this side equals this side. So everything about these triangles is the same. Not only the sides, but also the angles. So this angle equals this angle equals this angle, and this angle over here equals this angle over here. Okay, so they got all three sides, all three angles equal. The difference between congruent and similar is that similar triangles have the same shape, but not necessarily the same size. So let me write that over here, not the same size. So imagine that I have a triangle, okay, and it looks like this, okay, and I put it in the photocopier and I enlarge it. So now it looks like this. So same triangle, same shape, but bigger, all right? So let's say I put some side lengths on here. Let's say that this is 2 and this is, I don't know, 3. And we'll just pick a number over here. Let's say that this is, I don't know, 4.5, okay? And then this one over here is going to be an enlargement, which means it's going to take the smaller triangle and multiply it by something to get the second triangle. So I would go into the photocopier and hit times 2, okay? So I can create a new one that's double the size of the old one. So my side length that's 2 is now going to be 4, and the one that's 3 is now going to be 6, and the one that's 4.5 is going to be 9. And these two triangles are similar because I enlarged the smaller one to make the bigger one. This 2 that I multiply by has a name. In math, it's called the scale factor. So I have scaled my smaller triangle by a factor of 2 to get my bigger triangle. All right, so how this is useful is that sometimes we want to find information in a triangle that's hard to find. So let's say, for example, I have a triangle, I have CN Tower, okay, which is really tall. I don't know the height, all right, but I have somebody on the ground that's standing a certain distance from the base of the tower, and the sun is shining. Well, the sun will cast a shadow on the ground there. So let's say, for example, that it casts a shadow that is 200 meters long, and we want to find the height of the CN Tower. So right now, there's not enough information to find H. But suppose I had more information because I had like another thing. So let's say a statue of some kind, okay, some kind of statue that at the same time, with the same sun in the same position, is also making a shadow. Okay, and that the shadow that the statue makes is 2 meters. And what if I knew the height of the statue is 5.5 meters? Okay, now I have a situation of similar triangles because I have, this one is a right angle because it's 90 degrees, okay, because the CN Tower is perpendicular to the ground. And this one is a right angle because the statue is perpendicular to the ground. So we have one angle that's the same in both. It's the same sun that's casting a shadow, so it's the shadow, the sun is going to hit the ground at the same angle. So we have that this angle here equals this angle here. And we know that if two of the angles are the same, the third one must also be the same because the third one is 180 degrees minus 90 degrees minus that circle angle that I made, right? So the third one's also going to be the same. So all of the angles are the same. So therefore the triangles are similar. Okay, now how is that helpful? I can look at my two triangles and see, can I figure out how to get this height now? This thing is the same shape, so it's just been scaled. The small triangle has been scaled. What's the scale factor? Well, let's see, from 2 meters to 200 meters, that's multiplying by 100. So that's a scale factor of 100. Which means to get the height of the CN Tower, I'm going to take my 5.5 and multiply it by 100. And I'm going to get 550 meters. Okay, so that's how similar triangles are useful because we can use information in the smaller triangle to find information in a triangle that's hard to access. Okay, so that's similar triangles. Now, before we do this math of finding h, I had to go through this talking about why the triangles are similar. So first you have to show that the triangles are similar. And one of the ways to show them is all angles are the same. Okay, and then once you do that, then you can use the proportions. You can find the scale factor and figure out the missing side. Okay, let me do another one. I'm going to grab one from the textbook, and it's going to look like this. Here's triangle, so this is an example. Okay, so I'm going to make a triangle, and I'm going to call it triangle PQR. Okay, and this is, we'll put an angle here with a little circle, and I'll put an angle here with a little x. Okay, and I'll give some side lengths. So this is 5.2, this is 4.5, and this is a 6. All right, now in the other triangle, so let's make another triangle, and maybe I won't draw it in the same orientation. Maybe I draw it this way. This is angle, this is the little x. We'll put the little circle over here. So when you see the x and the x, those angles are the same, and the circle and the circle, those angles are the same. And so now I'm going to put a 3.6 right there. Okay, and the question is, are these two triangles similar? Let me give letters to the other one. Let's call it DEF. Okay, you could really pick any 3 letters. Doesn't have to even be in order. So we're looking at these two things and we're trying to figure out if the triangles are the same. Do they have the same shape? Well, if they have all 3 angles the same, then they're the same shape. So let's see. We know that angle P, the little circle, equals angle F. So I'm going to write it like this. Angle P equals angle F. Why? Because that's given with the little circle. I know that angle Q equals angle E. Why? Because that's given with the little x. Okay, and then the last thing, I'm going to know that angle R is equal to angle D. Okay, and that's because it's going to be 180 minus the other ones, so minus the O and minus the X. Okay, so both of those would be calculated as 180 minus the other 2, so they're going to have the same value. So therefore, we're going to conclude that the two triangles are similar. Watch very carefully as I write the letters here. Triangle PQR is similar to, now I'm going to call it DEF, but not because the letters are in order. It's going to be because angle P, actually it's not DEF, is it? Oh, great. Okay, it's not. Watch carefully. Angle P, the little circle, is equal to angle F, the little circle. So they go together. In the order has to match with the angles that are the same. Angle Q on the left has the little x, and that's the same as angle E on the right because it has a little x. And then angle R on the left is the one that we'd have to calculate. That's the same as angle D that we'd have to calculate. So basically these two triangles are similar, but the letters are important because these two are equal, and then the other two are equal, and then the other two are equal. Okay, so the lettering is very important. Once we know that they're similar, we can say, well, there's a scale factor. One of them is a certain number multiplied by the other. Okay, now this 3.6, the EF, corresponds to the 5.2 because you see the 3.6 is between the little angles X and O, and on the left, the 5.2 is between the little angles X and O. So this side EF divided by the side PQ is going to be the same ratio, right? Because there's going to be a scale factor that's going to be for all of them. That's the same ratio as any of the others. So let me put some variables here. Let's call it A and B. Okay, so it's going to be the same ratio as little a over, which is this side in the left that is corresponding to little a. Well, you can see little a is across from the circle. So on the left, across from the circle is the 4.5. So what I'm doing here is I'm setting up a proportion. Because there's a scale factor, I know that each side, if you multiply by the same number, you're going to get the length in the other triangle. So I'm going to set up the ratios, and I know the ratios are the same. Sorry, I set it up a little bit wrong. I should have written that this, so EF over PQ is equal to DE, okay, which is little a, over QR. Now when I put the numbers in, it'll be a little bit easier to look at. 3.6 over 5.2 equals A over 4.5. Okay, and now I can solve for A. So to solve this, you can clear the fraction, multiply both sides by the denominators, and then reduce. But a shortcut to that is to cross multiply. So 5.2 times A equals 3.6 times 4.5. Okay, and so just in the calculator, 5.2A, sorry, just grabbing my calculator, is 3.6 times 4.5, so 16.2. So 5.2A is equal to 16.2, and then I'm going to divide both sides by 5.2, and I get A is approximately equal to, A is approximately equal to 3.11. Okay, whatever the units are. All right, and do the same thing for B. For little b, so side DF, I'll go on the side. So side DF is on the right-hand side corresponds to side PR on the left-hand side because they're both across from the little x. And so that equals to, again, EF over PQ. And if I put my letters in, then I get little b over 6 equals 3.6 over 5.2. Cross multiply, 5.2b equals 6 times 3.6. All right, and so 5.2b equals 6 times 3.6, 21.6, which means b is equal to 21.6 divided by 5.2, which is approximately 4.15. Okay, and that's how we figure out the missing side. So first things first is you have to show that the triangles are similar. Once you show that they're similar, then you can solve for the missing sides. And the last point to make about this, because there's a lot of applications, lots of word problems related to similar triangles, which you're going to need to try. The last point to make is about the areas of similar triangles. So let's say I have a triangle and it's got a scale factor of 3, okay, to get to the bigger one. All right, so let's say that's times 3. How do their areas relate? So the scale factor of the length is 3. So the scale factor of the areas is what? Do you think that the areas will also be times 3? So you can take a number and you can take a triangle and put some side lengths on, calculate the area, and then do another one where all the sides are times 3 and calculate that area and see what happens. But I'll just do it algebraically. This area of this triangle is base times height divided by 2. If I take all the dimensions and multiply them by 3, then I'm going to get the area of the new one is 3b times 3h divided by 2, right? Each one of them, base and height, is all times 3. Every length is times 3. So that's 9 times base times height divided by 2. So what happened was the areas are scaled by 9. The reason this is happening is each of the dimensions is multiplied by 3. And since there are 2 dimensions, base and height, we're multiplying by 3 twice, which means the scale factor of the areas is the square of the scale factor of the lengths. Okay, so if you know 2 triangles are similar and you know the area of one of them, you can figure out the area of the other one by squaring the scale factor. Okay, so lots of stuff to practice, especially lots of word problems. Make sure you're always showing that the triangles are similar before you do any calculations. Okay, please practice. Thanks for watching.